So again, I am Max. I am a first year graduate student at the Physiological Ecology of Reptiles lab at Cal Poly San Luis Obispo. So I work with Dr. Emily Taylor, who many of you are familiar with, like rattlesnakes and the research that's going on with them lately. You'll know that's a really big name. So she's a great advisor, and I'm really lucky to be able to work in her lab on some really cool research. So today I'm here to talk about Project RattleCam, which is the latest phase of research coming out of Dr. Taylor's lab, and it focuses, as I showed here, like looking at the secret lives of rattlesnakes and changing public perceptions through the process. So there's a little bit of a why as to like this study is important.
Sorry, they can hear you, but just a little slower. And we're good.
Okay.
Yeah, there's no microphone, we don't need it, as long as you're just a little slower.
All right,
They can
cool.
hear you. Cool.
So there is some like more backstory to like why this is important, but before I get to that, I'm going to start with the backstory of this project. Here is Emily Taylor, my advisor. She has done a lot of work studying the physiology of rattlesnakes and fence lizards in her lab, especially rattlesnakes and fence lizards here in California, especially along the central coast near Cal Poly. And she also has these collaborators from across the coast, Scott Boback and Scott Goetz. We refer to as the Scots. They have all been colleagues for a very long time and have done a lot of really cool physiological research on reptiles, including rattlesnakes. And so the story of Project RattleCam begins with Scott Boback right here, and one day in the Rockies of Colorado. So he's into hunting big game, and so he was at this private ranch in Colorado, kind of like in the northern Colorado Rockies, and he was looking around for like elk while he was hunting, and he noticed this big rock formation up here on this hill. And so what he, being a reptile person and knowing about snakes and stuff like that, he's like, I bet there's rattlesnakes at the top of that rock formation. So he actually hiked up there, and just to give some background on what this place looks like, you can see there's like, this is that rock formation from a different angle. There's like the cow ranchers that are out there, and then here's like a far like more different view of the angle. So you can see it's this like, kind of like in this sagebrush grassland, kind of like high elevation ecosystem with like mountains in the background. And so he hiked up there thinking that there would be rattlesnakes. And you can see that the hike was quite a lot once you got up there. Like, great view of the landscape. It is definitely quite the climb to get up there. But he was right that there were rattlesnakes up there, and there were lots of rattlesnakes, prairie rattlesnakes. And so it's very, very cool system that you're kind of just up in this really high elevation area, kind of like one of the highest elevation areas that rattlesnakes actually have been found living at. And there's just these huge dens of prairie rattlesnakes. And how big are these dens? Well, they are very big. There is a lot of snakes here. So this research that I'm kind of leading up to, they actually were able to like count and get population estimates of how many rattlesnakes were in this den site here. And it's definitely hundreds of snakes and probably over 1,000 snakes. So it is, as of this time, one of the largest, if not the largest, concentrations of rattlesnakes that we know of in the world. So it's a really cool site with like this huge number of snakes that we don't see in many other places, and it's high up in elevation. So a really cool study system. So once Scott found out about this, I was like talking to his colleagues, then they're like, we need to go up there and we need to like catch the snakes and start studying this population. And so this was actually around the time of COVID. So once COVID hit and everyone had all of their plans or would-be plans like ruined because everyone was kind of locked down. They decided that late spring and summer they were going to go out to this site in Colorado, and they were going to do a capture, mark, and recapture study of the rattlesnakes there. And so they did that, giving them unique rattle combinations and taking data on as many snakes as they could catch. But another thing that they were really interested in doing is kind of not just marking the snakes, but also like seeing how many they saw over time. So they didn't want to like catch a snake and then catch the same individual later to like say that they saw it, because these snakes, when you do go up to them at these dens, like they're really warmed up, and once they see you approaching, they will just go back into their holes, and so they will go away. So in order to actually observe these snakes and see the same individuals again and again, what you have to do is use camera traps to study them. So that's what you can kind of see here. They have a remote camera with kind of like a shelter aimed at this den area where you can see like a huge huddle of snakes that's located here. So they set up these camera traps at 2 different locations in this den site. One is actually a den, which is where snakes will actually go in and hibernate during the winter. And then the other location is a rookery, which is where during the summer pregnant females will kind of hang out those sites while they're kind of incubating their offspring inside until they give birth. So they set up these cameras to watch the rattlesnakes. They also put out these operative temperature models, or OTMs for short. And what this basically is it's like a PVC piping that's like colored to have the same sort of pattern as a snake, and there's like a data logger inside that takes temperature. So it's kind of rough. You can see it's like not exactly like the snakes, but what this gets is kind of like an estimate of the available body temperatures available to snakes. So if a snake is just sitting out in the sun, what's the temperature of that snake? What temperatures are theoretically available to it? Or if you put it in the shade, what's the temperature of a snake sitting in the shade? So it's a more precise way to kind of get at the body temperature of these animals without actually measuring it. So they were doing both of these parts research at the same time. And with the camera trap data, they would get lots of pictures like this. So this is just one example picture from that camera you saw a second ago, and it's kind of just aimed here. And you can see there's several snakes at this den, and you can see one of like the den entrances. There's like a hole right in there. So I got all of these images, and some of them are just where like snakes are here, kind of just coiled about. Some have had the snakes that they had marked on the camera. And you can actually see some of those here where there's these colored rattles. So they give each snake a 3-color combination that they captured. And so they just had all this data from a full season of these camera traps. And just to kind of give you an idea of what a year in the life of these rattlesnakes is like, as I mentioned, they kind of hibernate during the winter. In Colorado and the Rockies, you can imagine it gets very cold, several feet of snow for several months of the year. So these snakes are just going into those holes. And then once it comes around early May, the snakes actually start to emerge. There's a period where there's all these adults in these big groups that are all kind of like huddled together and getting ready to leave. So May and early June, you have it where there's all the adults there. And then in mid-June, all of the females that are not giving birth that season, all of the juveniles and all of the males leave the den, and they kind of go into those surroundings. So if you think back to the images of the site here, we have our den up here. So all of those individuals that aren't going to hang out at the den, because they need to eat and they need to mate, all of those individuals are kind of going to go down the hill into these lower shrublands and grasslands, and they're going to spend their summer there. The only ones that stay at the den site longer into the summer are the pregnant females, which you can actually kind of see here in this image, like you can see just how swollen the back end of this snake is. So that's a pregnant female that, and this was taken in August. So this snake is probably very close to like giving birth. So most of the summer, it's just those pregnant females. Then around mid-August, a little bit later than I'm shown here, that's when most of the females give birth. And so then you have all the little baby snakes running around, which I will have pictures in later slides. And then it's really just like the females and those baby snakes for mid-August, mid-September. Then all of the other snakes that went out and foraged come back. And then in like early October, they all go underground and get ready for winter again. So there's a lot of that to capture on like all these images. So they were taking, these cameras were taking images throughout the whole active season, so all of that is captured on that data. And so they were taking, these cameras were taking images every 5 minutes. So as you can imagine, that's a lot of data. So it's way too much for a researcher to just individually go through or have like their undergrads or graduate students go through. That's a huge amount of data to go through. So what they did was they actually created a Zooniverse project to kind of help with this. How many people have heard of Zooniverse before? Okay, so it's this really cool citizen science website that you know, there's different kinds of citizen science. There's like iNaturalist, that's a really popular one, eBird, and then for herps we have NAHerp and HerpMapper. But Zooniverse kind of has a specific focus. It's all about sorting images and collecting data from images. So a lot of the studies you get are camera trap studies where there's just all of these images that have been generated, and you know, just your standard person can go on, follow the directions that are provided, and like sort through the images. And so all of you could open up a Zooniverse account and could start helping projects that are out there. Like all you have to do is just like create an account and then look at any of the projects and then start looking for photos. So I've used to help out with a bunch of these projects before, and it's really cool to just see like, you know, you could do a project with like game cameras in Africa, see like what hoofstock are like showing up on the camera. So definitely a really cool thing to check out if you're not familiar with. But we basically, Dr. Emily Taylor started off Project RattleCam this way through Zooniverse, and so this was kind of the initial drive to like create this project about watching rattlesnakes with cameras. And so this data, we're still looking through it. There's still a whole bunch of questions that can be answered, and we'll kind of get to it later in my talk. Part of this will actually be used in my own thesis research for graduate school. But just a few things that are kind of noteworthy from this is like some different things that we're discovering. One is that even at this high elevation site where it gets very cold at night during the summers, the snakes were still active at night. So you can see like these are kind of just hanging out by like the entrance of like the den. This one's actually like moving around. This one is probably also one that has a marked rattle, as you can see like the rattle color here.
Quick question, did you ever take the temperature at night of that particular area if heat wasn't emitting from the rocks?
So the only temperature that they got for like this earlier data was the operative temperature models, which probably wouldn't be a good measure of like the rock heat. And then also this temperature that's measured by the actual camera that they had. So the operative temperature model would probably be the closest thing to the rocks, but no, they didn't have something directly measuring it. But yeah, that's a good thought because this was relatively early in the night, so these rocks could have still been retaining some heat, and so they might have been there just because of that. This is one very interesting find, and just thinking about snakes at high elevation being active at night, you'd normally think like expect nocturnal snakes to be at low elevations when it's really hot. So just kind of a weird find, and we're kind of more interested in seeing more about that. Another behavior that we really got to see quite a bit that was really cool is this, which is right here. So it kind of, if you don't know what you're looking at, it kind of just looks like there's a bunch of rattlesnakes here, and they're all kind of coiled up, which doesn't seem that special. Rattlesnakes coil up all the time. But you also notice that this one snake looks really flat. You can see the body is like really laterally compressed, which is very weird. Like, why is a rattlesnake looking like that? And the reason is because this image was taken during a summer rainstorm. So every once in a while, you will get these afternoon rainstorms that happen in the Rocky Mountains, just because, you know, the heat is causing all the evaporation, and then all that moisture condenses on the mountains and then falls as rain. And that is really important for rattlesnakes, because for a long time there was a misconception that rattlesnakes don't drink. They get all of their internal fluids from the food that they eat. But research has shown that's actually not true. Rattlesnakes do not get sufficient moisture just from what they eat. They actually have to drink water. And so they actually have very special shapes on their scales that actually allow water to bind to it so it doesn't flow off, and it will actually stick onto them. So they basically flatten out and kind of create a bowl out of their bodies that water kind of just sticks to, and then they will drink off of themselves, kind of just everything that's on them. Or like this one, they'll drink off of their neighbor too. Yeah, so it's this really cool behavior, and it's, as I'll show in a later slide, it's not just the prairie rattlesnakes. Other rattlesnakes do this too. Yeah. Yeah, and it's like, here's like a little baby also drinking
Yeah,
off
there's a
the mom.
baby, the one that's closest to the bottom, is that a baby sitting?
Yep, this is a baby right here drinking off the drop off the female too. So yeah, it's, they don't just drink off of themselves, they drink off each other. And so I'm working on this project, my current research with Owen Bakhuber, another graduate student in the lab, and he's mostly interested, I'll talk about my research later, but he's mostly interested in the social dynamics of the snakes and kind of understanding their interactions. So like, he's really interested in understanding, like, is this baby drinking from like its aunt or its mother,
Yeah.
or is it drinking from just like a total stranger? Like, kind of understanding, you know, all these relations of how the snakes are coming together. So it's like there's a whole bunch of unanswered questions you can kind of just see in this one image. But this is like really cool to see, because it's very arid where these rattlesnakes live. You'd think, you know, being in the mountains and it snows there, that there'd be moisture and water wouldn't be a limiting factor. But the truth is, once the snow melts and it becomes warm for these snakes to be out, it gets very dry, and these like infrequent afternoon storms are really the only moisture that these snakes have when they're just sitting here at the den. So it's very important to have these storms, and so almost every storm that happens, you will see the snakes like do this behavior. Another really interesting thing that we got to see with this footage, or these images, is also what other animals use the den. So this is a common hornbill. It's a nocturnal bird that feeds on insects, not snakes, but it's hanging out right at the entrance of the den.
Yeah.
So this is the same spot as right there.
Right, everything is right.
So it's really interesting because other animals are also using this den. We've also gotten pictures of coyotes passing through the camera here several times. And my colleague Owen is also really interested in kind of using the data that we're gonna get with our newer projects to kind of understand like the predation, you know, pressures on the den from these predators that kind of come in, and understanding how like the snake social interactions might act to you know, protect the snakes from predators coming towards the den. Because like, if you just think about these baby snakes all together, that's a lot of delicious noodles for a predator to go eat. So it really is this concentrated food source. So kind of understanding that dynamic is one thing that we've kind of just gotten a glimpse into, but there's so much more that we need to learn about it. So that's the original camera trap study that led to the creation of Project RattleCam. And again, we still have all that data. There's a lot more questions that we can answer with it. But this kind of then led to the next phase of it by seeing how much the community scientists on Zooniverse really engaged with this work. So we had a bunch of people that were really interested in like going through all these images and filtering out what was there and collecting the data for us. So this got Emily, my advisor, really thinking about how it could be possible to engage the public with rattlesnake research and kind of make people think about snakes in a different way. So this led to the creation of another camera project, this time with rattlesnakes in coastal California. So before I say more about that, I do want to give a little bit of background. So
So pretty.
here's a rattlesnake. This is probably one of the stereotypical images that comes to your mind when you think of a rattlesnake. So like it's got the tongue there, it's got the rattle up, it's like in the S-shaped posture. It's like, I think most people would have some similar image to this when they think of what a rattlesnake is. But the truth is, when you think about it, that's not what rattlesnakes are normally like. This is only what happens when they sense a threat and they feel that they need to protect themselves. So if someone's hiking on the trail and accidentally disturb the rattlesnake, then the rattlesnake rears up like this. If you're field herping and you go road cruising and then you find a snake on the road and it doesn't like that you found it, it does this. But other than that, rattlesnakes aren't really like that. What they do is this. They kind of just sit there. Here's like a really pregnant female rattlesnake, and you can see like really thick there. And it's just basking at the entrance of like a den. It's not trying to be intimidating. If like the photographer who took this picture is kind of just sitting there and not bothering it, it's unbothered. It just sits there. And not only are these snakes usually not very aggressive, but they also, so we've kind of seen already, they can be really caring as well. So like here's a female rattlesnake with a little baby rattlesnake.
So cute. Oh my gosh.
So there's all of this part of rattlesnakes that I think the general public doesn't have come to mind when they think about rattlesnakes. There's also the ecosystem services, the like almost measurable benefits of like rattlesnakes, like they eat rodents, they control disease. All of those things are part of the everyday life of rattlesnakes. Yet people don't really think about that when they think of rattlesnakes. They think of this very intimidating thing.
It's a great photo, by the way.
I know, it's
Thank you.
stunning.
Thank you. So the part of why people experience this is because this is what we see when we go and we interact with rattlesnakes. There's also probably some support that this sort of thing might be, that I'm going to show, is a reason why people think about rattlesnakes. So as I show a little bit from this clip from National Geographic, just take a moment while you're watching this to kind of think about what parts of the snake are being emphasized here.
Rattlesnakes are more upfront than bushmasters. They use their noisy tails to back off and kill you.
All right, so what sort of things kind of jumped out at you about this?
How it looks intimidating.
Yeah. Anything else?
Rattle, tongue clicking, very
Yeah.
stereotypical.
Yeah,
It's
yeah.
a defensive posture.
Yeah, defensive posture, yeah, tongue clicking, rattling. Yeah, so those are all the things that kind of get emphasized by this. So all those things like, as you said, like intimidating, all those intimidating parts about a snake when it feels threatened are the things that are being shown here. And this is generally when you see documentaries and the dramatized like TV and stuff like that about rattlesnakes, this is what you see. You don't see that part about them being, you know, having like babies and kind of just being chill. So there's basically this this PR battle where rattlesnakes are being portrayed this way, and so people start to think that that's what rattlesnakes are like all the time. But as we saw, that's just one part of rattlesnakes. Rattlesnakes are also, you know, caring parents and important rodent controllers in the ecosystems. They have a very important role to play. So the real question is, how can we get people from thinking that rattlesnakes are like this to thinking that they're like this and recognizing that that is what they're like? So to do this, the next phase of Project RattleCam was to add a new camera to kind of attempt a new way at kind of making it where people see rattlesnakes a different way. So here's this camera that Emily installed at a den site locally in San Luis Obispo, kind of nearby that area. A site with, I believe, 6 to 10 snakes, around that number that you use it. And so it's very local down here, you can see one of the snakes. And so, of course, part of this was kind of to study rattlesnake behavior. Same with the camera trap study that was done before. But there was an additional purpose to this time, which was to actually engage the public and create a live stream. So this is the Project RattleCam Facebook page, and this, along with the YouTube channel, was created in order to make it where this camera and what we're watching is not just about the researchers learning about rattlesnakes, but it's also an opportunity for everyday people to be able to just go on YouTube and watch rattlesnakes or check in on the Facebook updates and see what's happening at the den. So it was very much made with this idea that by engaging the people in what rattlesnakes are actually doing and studying an actual den where they're not being disturbed, it's just their behavior, that maybe people will come to see that these snakes are not like this intimidating presence that they're often portrayed as. So that is what the goal of this California live streaming camera has been. And I'm going to go into some of the highlights of what we've found about this, because there's also been a lot of really cool discoveries as far as like rattlesnake behavior and how they interact with the greater ecological community, much like the previous project. These are all things that are on the Project RattleCam YouTube, and you can go there and you can check it out as well. And all of our previous live streams that we've done are also recorded there, so all of that data is there and anyone can look at it. So first thing was, because this is a den, there are going to be female rattlesnakes and then their babies. So that was one thing that we saw, very similar to the den in Colorado. Of course, way fewer snakes than in Colorado, not as nearly as big of a den. But still, we're able to, this time, instead of with a camera trap, where we're only getting we're getting snapshots every 5 minutes. Here we have a camera that's actually recording video, and we're able to move the camera and zoom it in so that we can actually see, what we want to focus on. So here, this little newborn rattlesnake has kind of just crawled over to this female. Probably not the mother. It's probably a different snake, and yeah, he's just coiling up.
So cute.
Yeah. And so that reaction with the awe is kind of what we're hoping to get other people to kind of experience when they're watching this. So we kind of, because we're all more or less are interested in reptiles and amphibians, we're more familiar with snakes. So we don't have as much of like a bias against them. But hopefully, someone kind of just chill watching this on their TV or their computer can also feel relaxed, like the snakes are out there and they kind of just watch this, and maybe we can reel them in to understanding that these are really cool animals. Also realized I forgot to kind of talk about den and what it looks like. So I mentioned that the camera can zoom in, and so this is like a very zoomed in view. But if you zoom out, this is the kind of set position for what the camera looks like. So we have like the camera like positioned out here towards you, and there's this whole rock pile right here that like snakes like the basket, and right here is the main entrance to the den. So a lot of the snakes tend to use that. When you saw those, that female with the newborn snake, they were kind of here under this rock pile. And there's also the ability of it to rotate outwards, and it can rotate full 360 degrees. So we can actually see everything that's around it too. But if we see a snake that's out, we usually like zoom in so that we're actually able to like watch the one snake that's on the camera. So kind of continuing with the females and the babies, here's like photo of like the same sort of thing that we just saw a video of. But kind of to reiterate here, you can see that this is a pregnant female rattlesnake. The back end of the body is really swollen. So this is a snake that's probably going to give birth sometime soon. So that can't be its offspring, because this is a newborn snake that's born that season. So this kind of gets back to that idea that maybe snakes have relationships between sisters and aunts and nieces and stuff like that, because this snake is probably not directly related to this snake, but is there some other relation going on there? So that's something my colleague Owen is really interested in studying, and that's the focus of his research. Another thing that we got to see from this camera is male rattlesnakes pestering female rattlesnakes. So this is the female here, and this is the male, and you can see the female is not very interested. She's trying to hide her head from the male snake. And the male is doing kind of the jerky motion, which is what they usually do when they're interested in mating. That's kind of like, just to get the female snake into the mood. And then here is kind of cut off here, but this is like another snake entering the mix, and so this male is not too happy about it. But it was really interesting this past fall. We didn't see any babies at the den last fall and summer, which was really weird. We were expecting to see some baby snakes. And we also didn't see many females the whole time. And one of the reasons why is because there were all these males that were being very pushy, and they were kind of pestering the female snakes, and the females, we think, were just hiding in the back of the den because they didn't want to deal with the male snakes. So it was a very male-dominated fall and summer. Kind of reminded me of like when the Kens take over from the Barbie movie, and they just take over Barbie Land. It really felt like that last summer. Another really cool thing with all the male action was that we got to see some actual battling going on, which is what you can see here. I'd actually never seen video of this before watching this on the camera, and it's much more intense than I realized. But yeah, this is, some of you may be familiar with this behavior that rattlesnakes do, but they basically the males try to push each other down with their body and get on top. Yeah. And this isn't slowed down either, this is actual speed. Yeah. So yeah, they're trying to basically pin each other on top and like push the other one down, and whoever basically gets exhausted first loses the battle. Yeah, this clip went on for like a total of 15 minutes, so they were at this for a little while. That's actually not as long as battles have been recorded between males. Sometimes it can take way longer. Yeah, and then they came back out. They're still in it.
Wow. It's interesting because they're not, obviously they're not, whoa, they're not biting, and that's something we deal with a lot when we do outreach events. We have to explain that the snakes don't use their mouths to battle or fight, they use it to eat.
Mhm.
And here's a perfect example of that, you know,
Yeah.
where they clearly they're dominating, they wanna be the dominant male, but they're not fighting each other.
Yeah, and it's like the one that's most fit is the
Right.
one that ends
It's
up.
like a giant
winning
thumb
the
fight.
Yeah, here at this point at the end, with that big fro, one of them realized he was done.
Well, it's probably exhausting.
Yeah. So yeah, the one that was underneath that got thrown, he
Yeah.
went away, that's the end, so the other one just chased him away. Yeah, so, very, very cool, and this is all taking place right here at the den, and we were able to capture pretty much the whole thing,
Wow.
like on video. So this is like a really cool thing that, our lab, it's the first time anyone's done this with rattlesnakes, is to just be able to like get all of these like intimate looks in the lives of rattlesnakes without actually disturbing them. They're all just doing their own thing. None of this is cued. They're just doing it, and the camera's on when they're there.
You guys need a producer and do a documentary. Take all this footage and make a documentary. This would go a long way in helping people understand.
Yeah, yeah, yeah. There is some stuff we're working on that's similar to that.
Okay.
Yeah, I don't know if I can reveal full details on it yet, but yeah, hopefully
Great.
we'll have some stuff like that coming out in the future.
Public needs to know.
Yeah, yeah. Here's a female rattlesnake doing the drinking behavior that I kind of showed in the image earlier. So you can kind of see the sides of the mouth are like moving in and out. So that's the female like drinking off the back. And you can actually see like the raindrops coming through the screen as well. And this is one of our western rattlesnakes from California. So completely different species, completely different region. It's doing the same behavior. And here's it sped up so you can kind of see like the motion, like the face more.
So different snakes have different scalation, does that mean they don't do this? Are they like a king snake?
So I don't know about other species of snakes. I think it's definitely known that like the rattlesnakes do this. So the other snakes, yeah, if they have different scalation, they probably don't rely on it as much, or they have a different means for getting their water. Like they might have to rely on puddles as well. Because rattlesnakes will also drink from puddles too.
Yeah, I have a video when I was up in East Canyon, Schweitzer Falls, of a rattler went to the stream and drinking.
Yeah, yeah.
So I imagine it's easier to drink that way if you're out in the
Yeah, yeah, in certain places, definitely like that's probably an easier way, a more reliable way to get water. Similar to Colorado, this den is kind of like in a upper hill area where there's no like water source around there. So if the snakes want water, other than what comes with rain, they actually have to go and leave the den in order to get that water. So this is like another situation where if the female's gonna just sit there at the den the whole summer, they kind of rely on this for water. So you wouldn't think that a foggy or rainy day in the summer would be that great of a day for like a snake coming out, but it actually is a really good time for the rattlesnakes. I really liked the video that we got this season of the rattlesnakes battling, but this is probably my favorite video that we captured this past season. So this video was taken when a bird flew over the den. So we weren't able to tell what kind of bird it was because all you'll see is like the shadow. But watch what happens when that happens. So there's the shadow of the bird. So yeah, he puffed up, looked really big and doing the tongue flick.
Well, what's called?
And then, yeah, they just left. There's actually a second snake under there that was hard to see at the beginning, but yeah, you can kind of see he's like under here, and then you'll see the two rattles once the first one goes. Yeah, first rattle and the second rattle. Yeah. So yeah, they're interacting with all these other animals that come by the den. So maybe that was like a hawk, and the snakes didn't want to be out. Yeah, so then the snakes, yeah, then the snakes just go away. They don't want to risk being out when there's a bigger prey around. Interesting side note about that, one of Emily Taylor's previous grad students, Haley Crowell, who's currently a PhD student at the University of Michigan, is doing her research on snake UV color. So that's basically like if you're going to shine a UV light on like a snake, like what colors are being reflected or absorbed as far as UV wavelengths. And birds see in UV. So if a snake reflects UV wavelength, then they can be seen more easily by birds. And so there's what she's finding is there's this hidden dimension of UV color in snakes, where some snakes have a lot of reflectance, some have absorbance. And it probably relates to this, like being able to be detected by birds, because that's a really big predator of snakes. Yeah.
Did they release what the wavelength is that makes them luminesce or absorb?
So that I don't know what specific wavelength they're using in that study. It actually hasn't been published yet, so that study will come out soon. This is more like word of mouth, talking with them. But yeah, one thing that they did tell me is like the prairie rattlesnakes at the den that we're studying, they absorb all of the UV light. So they don't reflect any UV light, which means that if you're a hawk looking down on the landscape, those snakes don't stand out to you because they're not reflecting UV light.
It's like the Harry Potter cloak of invisibility.
Yeah. So it's kind of interesting to think about. There's this like dimension to how these snakes look to other animals that we just can't even think of. But this clip here kind of shows why that might be important. We've also had other visitors to the den as well. So this is a really cool clip as well. Yeah, this is a chaparral whip snake.
Oh, whoa!
Yeah, the snake kind of moved when the rattlesnake moved when he saw the striped racer. So the striped racer is kind of booking it and leaving. And then you can see the male. It's kind of an awkward angle, but the male snake is kind of like coming out. So yeah, here's the whip snake again. When these things happen on the camera, most of the time nothing's happening on the camera. So when something does happen, it's really hard to make it look good. So that's why the camera is all kind of jolted here.
So there's somebody monitoring real time.
Yep, there's always someone on the camera because we have to be able to like change it if something's happening. Like here's the male. See, he actually came out of the den to like make the snake go away. Yeah. So yeah, we always have someone on the camera who's actually watching this, and if we see something happening, then we can zoom in. Because our only way to actually document it is kind of like the full camera view. So if we want to actually zoom up and look on a specific thing, we have to zoom in with the camera. Otherwise, we're just going to get the full wide angle that the camera is taking video of. Yeah, I'll play that beginning part just one more time. The other thing I'll say is that it is well known that chaparral whip snakes are snake eaters as well. They will eat other kinds of snakes. And so this snake may have been going into the den searching if there are baby rattlesnakes that it could feed on. And so it's really interesting because there's this huge snake which definitely isn't a threat to that whip snake, the huge rattlesnake, but it's pushing it away. So is it like protecting the den against like, you know, predators? It doesn't want it, like the predators to eat like its offspring. Like it's kind of an interesting thing to think about. One final thing that happened at the den, that I was actually there when this happened. If you look at the upper left-hand corner,
Ah, yeah,
you'll notice a king snake
king snake.
Oh.
that's literally coming right out of the den.
Uh-oh.
Right.
That's
Yeah.
not good.
So the king snake was actually in the den at one
Uh-oh.
point. And this was the first time that we had seen this on the rattle cam, and one of the few, if not the only, like documented case where a king snake is actually in a rattlesnake den. So,
Why?
so it could be looking for the baby rattlesnakes to
Yeah.
eat. Yeah, because baby rattlesnakes are the perfect size for a king snake to eat. And inside the den would be where they were. We actually also saw a king snake on another occasion come to the den. It was actually in this section over here. So we think this may be one reason why we didn't see any babies this year, is that this rattlesnake or this king snake may have been
Yeah.
eating the few babies that there were.
Go eat rodents.
Is there any,
The mom and-
I mean, are you guys seeing like one female using several denning sites, so maybe they're moving if they're doing regular visits, or you can't track them that far yet?
Yeah, we aren't tracking like if they're going to other
So
places.
you're not doing any telemetry type of?
Yeah, not really with like these snakes yet. Yeah, one of the parts about like this research with Project Rattlecam is like trying to create ways to research these animals without actually like touching them or disturbing them. And so, yeah, there's a few limitations to that, but we're also the nice thing is we're able to just watch the same snakes again and again.
So these aren't eggs, it's the baby rattlesnakes, or they're not the baby rattlesnakes in the egg that the snake ate?
Yeah, so the king snake would be after the baby rattlesnakes.
Oh, it was.
And with rattlesnakes, they are actually viviparous, so they actually don't lay eggs.
Oh, okay.
They give birth to live young. And so, yeah, the only thing the king snake could be going for is
Yeah.
the small rattlesnakes.
This rattlesnakes out there,
Mhm.
they get stuff on.
Yeah. Another part that's really noteworthy that this brought up is we have several dedicated people who would always be watching the live stream during the summer. Like there's this one YouTube user, Jay, who would just always be on there, and he would be like noting what's going on with the snakes. He'd comment if he saw something. So we had this dedicated fan base that were really engaging with the live stream. And when this king snake came on, they were all like, "Oh no, I don't want it to eat our rattlesnakes." They were like very protective of the snakes, like thinking, "Oh, we don't want them to get eaten," which is a really nice thing, kind of showing that this live stream might be doing
Yeah.
what we're hoping, because they're actually like being protective of the snakes
Yeah.
and seeing the rattlesnakes as kind of like the good guys in this story. So that was kind of one way to show that this live stream is kind of moving that direction. But also, it's only a few people that were watching it regularly, so we had a pretty small audience. So we're really interested in trying to push this to the next level and make it where we have a bigger audience and more people will get to watch this. So how do we plan to do that? Well, basically, we want to go back to where it all began, in Colorado. And so we're going to basically take the best parts of the two phases of Project Rattlecam that have happened so far and combine them into one new thing. So we're gonna take the population of rattlesnakes that was here at this high elevation location in Colorado, but instead of looking at it with camera traps, we're gonna be looking at it with a live streaming camera. And it's not gonna be the exact same location as before, but a nearby den site. So this was Rattlesnake Butte, which is where our previous research took place. And then right here on this hill or nearby is a smaller, lower elevation area. It's a little easier to get to. And it has this rock outcrop, which you can see right here. And so the snakes will just bask in a few different areas around these rock formations. So we're planning on having the live streaming camera right there looking at these snakes. So now we will be able to focus on a den site of prairie rattlesnakes where there will be hundreds of snakes. So instead of having the live streaming camera where there's just a few regular snakes that we see again and again, we will literally have so many snakes it's going to be hard to keep track of which snakes we're looking at.
It'll be different kinds of snakes, it'll be different kinds.
Yes, yes, yeah. So these will be prairie rattlesnakes that we're looking at.
Oh, prairie rattlesnake.
Prairie rattlesnakes, yes. Whereas the ones that I just showed the videos of, those are western rattlesnakes.
Got it.
So this is my colleague Owen, by the way. So we have two different separate thesis projects that we're working on, but we're both working on Project Rattlecamp. So all of our work kind of mingles together, and so it's been really great to learn from Owen so far, and to kind of work together on these different projects. But here we're kind of showing you the equipment that's going to be installed at this new site. So this is a security camera from Axis Communications. It has day vision and night vision. So we're actually going to have a 24-hour live stream across the whole active season, which, as far as we can tell, that's never been done before for a wild animal. So have it as a 24/7 live stream over the entire active season of like a wild reptile. So really cool stuff, and we have less than a month till launch. Literally the end of April, this camera is going to be going up there. But yes, we have this camera from Axis Communications, and then here is like the whole battery system and like console, and it's weatherproofing. So this was all custom made by the engineering staff at the Frost Center at Cal Poly. And then behind us, you can also see the enormous solar panels that are going to be placed up there to charge it. And you can see how tall I am, and this is being taken, this photo is taken on like a ladder. So you can see that those solar panels are huge. Here's like kind of a close-up at of all of like the battery and setup. So it's very, very complicated. We've been trying to make sure every little thing is right, and we foresee every possible error, because once we put this thing out there, we're gonna just leave it there for 5 or 6 months before coming back to it. And ideally, we would need minimal maintenance on it. So yeah, everyone in the lab and the engineering department is really stressed right now because the moment of truth is coming up.
So this is on private land, right?
Yes, so this is a private ranch.
So
We
it's
have,
not gonna be accessible for,
yes, yeah, so yeah, the public won't be able to get there, so the camera's safe that way, and we have permission with the landowner to do all this research. Here's just a closer up view of like the camera, so that you can see that. So yeah, this really cool setup. It's really like just made specifically for this project. And hopefully, if our research is successful in this way, other researchers can also use this setup. So we're studying snakes, but maybe someone can use this to study other animals as well, maybe like seals, like a rookery. Or we could do stuff with other reptiles too, like if we have a group of lizards that like uses a specific rock formation. There's many different ways that we can kind of use this to study animals in like this kind of like disturbance-free method.
Like we need to check well a lot.
Yeah.
You did what you read my mind.
It's just coming out of your vibes.
Right.
Yeah. So now to kind of get, I've been talking more broadly about the project in general, Project Rattlecamp, but there's a little bit more I want to go into about specifically what I'm going to be looking at with my research. But before I can get into that, I want to be the bearer of bad news and tell you all that global surface temperatures are increasing. This graph's from NOAA showing kind of like the anomalies in surface temperature, and you can see that the trend's pretty clear. Surface temperatures are really increasing. So there's been a lot of research on how climate change is impacting the diversity of reptiles and amphibians, and overall there's been a lot of declines because of this. So it's really important to understand how changing climate is going to impact reptile populations, so we can kind of make predictions about how they will react to certain changes and how we expect ecosystems to change in the future. So climate change is really hard to study because climate happens over a long-term scale. So it would take many years to study climate. So if you can study a system where the weather changes often, and you're able to document those changes and watch the shorter term changes in behavior of a reptile, that can give you more feasibility in being able to see how changing climate may impact reptiles. And so our system that we have here with these prairie rattlesnakes at this site in Colorado is kind of perfect for testing this. And the main reason is because they're located at this high elevation site, which, to start off with, high elevation sites get very extreme weather conditions, kind of all times of the year. So it can be like very cold at night, and then it gets very hot during the day during the summer, or you can just be during the wintertime where it's really cold all the time. You can also have really strong winds as well. So there's all of these really harsh conditions and all these changes in conditions that can kind of impact how reptiles behave. And another reason that the prairie rattlesnake is good for understanding how reptiles change in high elevations is for two reasons. Number one, they change their behavior a lot in response to the weather. So if you think about a snake, it can coil up, or it can stretch out, it can move into the shade, or it can move fully into the sun. It can change what part of its body is in the sun, and it can do all these different things to kind of facilitate maintaining its body temperature and everything else that goes on with its physiology. Another reason that the prairie rattlesnake is really great for this too is that prairie rattlesnakes are a generalist species. So they're not specifically high elevation adapted. They really just occur in lots of habitats. So grassland and desert in the Chihuahuan Desert, but they can also be found in boreal forests and these high elevation sage habitats. So they really cover a huge range of habitats and elevations. So by studying this species, we're not just seeing how a very limited niche species works, but we're also able to see how a very flexible and adaptable species is able to change its behavior in response to weather. So within the system, what I'm going to be looking at is kind of how behavioral homeostasis is impacted by bioclimatic variables, and specifically how this happens at high elevation. So to kind of get to that term, behavioral homeostasis, so these are a bunch of pictures of rattlesnakes at the original den site with the camera track data. And I kind of am showing this to show you just all of the different ways that rattlesnakes can kind of adjust their body position with the environment. So here we have one that's kind of just out. Here's one that's mostly sheltered away. Here's one that's very sheltered underneath. Here's one that's kind of like partially under some leaves. Here's one that's in a pretty tight coil. Here's one that's in a very loose coil. And then here's just a huddle of snakes. So they're all together. They could be like this where they're separate, but they've all kind of chosen to be in this big group that has its own thermal properties.
How come there's different colors on its rattle at the line?
So this one is one of the marked snakes that they marked. They
guys
marked,
marked it.
so they captured it and they marked
Oh,
it for
okay.
the study. Yeah, so that's why there's the color on those
Okay.
rattles. So the snakes are changing their behavior in this way, and they're doing this to facilitate their physiology, whether that's their digestion, their internal body temperature, blood circulation. There's all these different things that they're trying to facilitate by making sure that their body temperature and other things are at the right levels. So I am kind of referring to all these behaviors together as behavioral homeostasis. So the more typical term that herpetologists tend to use is behavioral thermoregulation, which also applies here. But the reason I'm going about this is two reasons. First of all, I want to more focus on the physiology of the snakes and kind of that bigger picture, thinking about how these snakes are focusing on that rather than just maintaining a specific temperature. But also, more recent research is showing that it's not just temperature that impacts these behaviors. Another topic that's kind of becoming a hot topic in reptile physiology is UV exposure and kind of photoregulation. So kind of choosing to be here or here, not just because of temperature, but also because of the need to have UV radiation to get like vitamin D and other things that we know that reptiles need and benefit from natural light. And there's actually a really cool study recently that was published in 2022 on eastern fence lizards, and they did it in the lab, and they created some different treatments with temperature, UV, and then both together. And they found that the fence lizards actually preferred to have their body temperatures higher when they were offered UV exposure. So they actually made it where they made UV exposure their highest priority, not temperature. So thinking about UV and the exposure from the sun may actually be more important than temperature. So that is why I'm kind of focusing on this, calling this homeostasis, because I want to accept that there may be these other factors that may be impacting the snakes. So what am I measuring? So what actual things am I measuring? Well, similar to our previous research, I am going to be using OTMs to measure operative temperature. One thing I'm actually going to be doing that's a little different is I'm going to be measuring the operative temperature for adult snakes and for newborn snakes. So the temperature you would get from this more typical OTM is really going to tell you what the temperature is of an adult snake basking in the sun. But newborn snakes are really small, and they have higher surface area to volume ratio than adult snakes. So they lose heat faster and they gain heat faster. So my thought is that they're probably going to thermoregulate or maintain homeostasis in different ways than an adult snake. And so by kind of having small and large OTMs, I'm hoping to kind of see if that's related to temperature specifically. I'm also going to be installing this weather station by Davis Instruments at the site, and I'm specifically going to be looking at the air temperature, UV index, humidity, and the wind speed. And so temperature is more obvious because that's one of the things that is really impacting these behaviors snakes are doing. UV index also is something that we know is impacting other reptiles, so I want to see if that's potentially playing something here. And humidity, I am kind of thinking about water loss for the skin. So another reason that snakes might coil up, like you see here, may actually just be to reduce their surface area so that they don't lose water as much as well. Because remember, this high elevation site is very dry. They don't have a lot of moisture, so they need to make sure they don't lose water. So by measuring the humidity, I'm thinking that might be a factor that also affects their behavior. And the last one up here, it's hard to really isolate why this factor is important here, but wind speed, it's been found that at higher wind speeds, generally snakes tend to be more sheltered and they don't actually go out there in the open. So just adding that in there is another thing that may be impacting why they're doing stuff. And then it kind of shows the different behaviors that I'm looking at, and there's a few other things I'm recording, but these are the ethograms that kind of define like the different terms and levels of these different behaviors that I'm looking at. And so you don't have to focus on the details here, but just to kind of like sum it up, I'm basically looking at different forms of how they're coiled, so their body position, so whether they're coiled more tightly or more loosely, or whether they're just not coiled at all, they're kind of stretched out. And then I'm also looking at how like exposed to the environment they are. So like they sheltered away to where they couldn't get any wind on them, or like it's all shade, or if they're actually like out in the open. And then the final thing I'm looking at is what I'm calling group huddling. So this is kind of when you have that big pile of snakes that's all together and it has its different thermal properties. So I'm kind of looking like at how tightly they huddle and how big of a group size it is, and seeing if those different factors that I want to measure kind of can serve as a proxy for determining, you know, are they going to be in bigger groups or are they going to be in more tightly huddled groups? So by measuring all these things, these are the different sort of questions I'm aiming at answering. So one of those is like, what are the environmental impacts on individual behaviors? So how are those behaviors that I just showed you impacted by the climate, and like what specific conditions cause those behaviors? What are the dominant conditions? So that's kind of more what I explained about. I'm also looking more specifically for the causes of group huddling. So why do the snakes all kind of get in like these groups, and kind of understanding that for adults and for newborn snakes. Is there like a difference in that dynamic? That also kind of goes into age-related differences in behavior. So like females and the newborn snakes have very different body sizes. So are they going to be doing different behaviors a lot of the time? Is the weather conditions going to impact them differently? And the last thing that I'm going to be focusing on is actually less involved with the live stream, and this is looking at seasonal changes in homeostatic behaviors. So this is where I'm actually going to use some of the camera trap data that was originally gotten in the original phase of Project RattleCam. And what I kind of want to see is with female snakes, we've noticed if it's a pregnant female that they will tend to put their the side of the body where the embryos are developing in the sun preferentially, which we think is to help increase the body temperature there, so that they can help facilitate the development of the embryos. Previous research has found actually that females do achieve higher body temperatures as the season goes on and they get closer to giving birth. So it would kind of make sense that maybe throughout the season they're actually like showing more of their backside to the sun as they bask. So basically I'm going to look at like the camera trap data with the marked females that were captured, and we have the data for them, and kind of see like throughout the season, do they change how they bask throughout the season? So those are the 4 different questions and we'll look at. And honestly, the ideas of what could happen is endless. There's so many different possible answers. So really, I just kind of want to get this camera up and then see what snakes do. So one thing they'll say is about having the snakes be coiled. I'm predicting that, you know, in general, if it's very cold or it's there's very low moisture, that snakes will probably be in tighter coils. So that makes sense. They don't want to lose heat. They don't want to lose moisture. And that's the same thing for being sheltered. Like snakes are probably going to hide away if they're going to lose water or lose heat. Same thing goes for like group huddling. If it's drier out and they could lose more water, or it's really cold, they're probably going to huddle in groups more than, let's say, if it was a really sunny day and it was all warm and very humid out. And then for age-related differences, I definitely think there's going to be some sort of difference in how the young behave and how the adults behave. So that one's going to be very tricky to answer just because of how different these 2 individuals are. But definitely, I think the main thing that I'm going to be looking at here is actually in the huddling behavior. So how do the newborn snakes huddle compared to the adults? And so kind of getting at why this matters for the end of my work. One thing that I kind of already alluded to is making predictions about future reptile ecology. So we have these snakes, we know that climate change is going to impact them in the future and that it's going to happen So how are they gonna change? We know those changes are gonna happen, so how are they gonna change, and how is that gonna impact the ecosystem? So we need to understand how they're gonna change behaviorally before we can understand how the ecosystem will be impacted. We also, through this, can study undisturbed rattlesnake behavior, which is something that has been really difficult over these time scales, like over the increments of like every hour studying those behaviors and doing it for a full active season. That's something that just hasn't been done that much because there's been so many limitations. So with this live streaming technology, we can actually kind of go over some of those limitations and answer these questions that weren't possible that long ago. And also, of course, getting to the main goal and mission of Project RattleCam is changing public perceptions. So we want to change how people feel about snakes, and by involving people in this research, we're hoping to do that. So just a few other things that are going on with Project RattleCam's work. I already mentioned a lot about Owen's thesis work, which is focusing on the social lives of the rattlesnakes. So how does that relate to combating predation and kind of their other behaviors like drinking off the backs of their neighbors. But we also have some really cool projects that are more focused on the social aspect. And one of these is Rattle Ed, which is an education project. So we actually have already done some preliminary stuff with trying to take the live stream and get it into classrooms of elementary schools. And the initial results have been really great. Students in these elementary schools have been really interested in the live stream, and like every day they have wanted to go back and like see what's going on with snakes that day. So we're trying to make a more formal education curriculum that schools can utilize. And so we're working with some liberal studies students at Cal Poly to create a formal education curriculum that can be implemented easily by elementary school teachers and meet the state's like common like education standards. And so we're currently working on that. We have a good setup going already, and we're going to actually test it over the next few months. So that's a really cool project that's going on. And kind of related to that, we're also doing a snake drums perception test, or trying to develop it. So with this education outreach, we're gonna try and have it where at the beginning and end of this education, we ask students, draw a rattlesnake in its habitat and write a caption about your image. So we're trying to get, trying to use that data to kind of piece out how students feel about snakes. So our goal with this is that hopefully we'll be able to see that after this education curriculum, students will actually have more positive perceptions of snakes, which is what we want. We want to do that. So these things are both being developed right now. The snake drawings one, we definitely have a lot more work ahead of us, but this is really the bread and butter of what we want to do. We want to make sure that this is helping with community outreach and helping change how people feel about these animals. So if you want to watch some rattlesnakes with us, you should definitely go to Project RattleCam's YouTube channel where all of our videos are up there. The new camera in Colorado is being launched later this month. So at the start of May, it will be live. So you can go on Project RattleCam, and every day there will be a live stream, and you can go to the newest live stream at any time and check out what the rattlesnakes are doing. So I highly encourage you to do that. Please also spread the word about this around to anyone else you think would be interested, even just like casual nature lovers. Like we really want to make this widespread and to get it where, you know, not just herpetologists and herp enthusiasts are really interested in these animals. We want everyone to watch it. And you can also get updates on Facebook and Instagram, and we have a website that you actually can go to it right now. The URL is live, but we still have some construction going on, so we're hopefully going to have more of that fixed in the next month or two. And with that, I want to wrap up by saying that I want to thank Dr. Emily Taylor and my committee members, both the Scotts, for all of their work that they've done on this project so far. Owen for all his help, and all of the other people that have kind of helped me with this project so far, and all the different sources that are involved here. And with that, I'll be happy to take any questions. Yeah.
In Bouquet Canyon, or I guess it's, Saugus area, the rattlesnakes are, they're very scary looking, but they're like a real dark rattlesnake. I mean, the same design, but it's like, they're like almost like black, and they're very scary. It's like, they'll kill you. I mean, but I caught a few in a trash can with the shovel and the lid, and then put it in there, and then go in the car and then drive it further up, like where that dam is up there on a Bouquet Canyon, because I didn't want it near my cabin, so.
Yeah.
I've done twice skating rattlesnakes up there.
Mhm. Yeah. The ones around here can be very dark in coloration.
So, yeah, okay, so that's not in the valley area, like just the rattlesnake,
Yeah.
diamondback rattlesnake, but up there, they're darker.
Yeah, that's one of the really interesting things about our local rattlesnake, the western rattlesnake, is just there's so much variation in how they look. You can even drive to just like an adjacent mountain range and then they look different. So yeah, they're really cool.
And then in March, or beginning of March, I was in Sand Canyon, and I saw a rattlesnake in the street, and I'm going this way, and this car coming that way, and I think I was gonna get run over, and then it just went boom like that, with the car went by, and the snake went like that, like the wind, just, but it did get run over. It's like, so, but it was in March, I thought that was kind of strange, so they use summertime to see them out there. On the
Yeah.
street.
Yeah.
So they are out at that time too?
Yeah, there are rattlesnakes out right now. Yeah, so you definitely want to watch where you step when you're out there. But
When it's cold though, you're not gonna find them out on the trail or nearby.
yeah, generally when it's warmer.
Yeah, it was
but-
warm.
Every time I
Yeah.
said that, I was proved wrong.
Yeah, I've seen them out on the trail in January before, so they are out any time of year. Any time of the year around here, if it's warm enough, they can be out.
Well, I
Pretty
just had a
moderate
full moon
temperatures.
night hike and one guy came running down, he goes, okay, I checked the trail, there's no rattlesnakes. It's like 7, 8 o'clock at night, right?
So it's the temperature that is a factor with it.
Imagine-
Yeah.
It's really cold.
Okay, yeah,
Yeah.
it wouldn't be one.
I was like, I'm not gonna say.
Yeah.
Your buddy Owen, how is he going to be taking tissue samples and looking at DNA analysis? How's he gonna know, just determine the family relationships between the individuals and the colony?
Yeah, so that's a good question. I definitely don't have all the details on his project. But one of the cool things with the original population that we have all the camera trap data for is they did get like blood samples from every snake that they caught. So every marked snake, they have like the blood and they can get the DNA and know about that. We currently have it at a lab that's supposed to be processing it, but it's going very slowly. And so I don't know if it's gonna be there in time for like Owen and his work. But if that data did come back, we would be able to like know how every snake that was captured is related to each other. But if he doesn't get that data, it's kind of going to be, there's just a lot more challenges because you have to identify individual snakes. So that part we're still working out of our projects. And even mine, like with categorizing the behaviors, there's a lot of stuff that we're going to kind of just have to test and hope that it works out. Because it's a new research method, so we're having to create brand new methods that have never been tried before because of that.
I have kind of a sideways question.
Yeah.
So, I've come across kind of randomly, kind of some podcasts that include kind of some talks about this type of thing. Are there any podcasts or kind of current information, but not necessarily published information that you guys are interested in listening to or that you would recommend to others?
As far as like just general like herp podcasts, the So Much Pingle podcast, I really like that one.
Okay.
So, yeah.
What's it called?
So Much Pingle.
Okay.
It's Mike Pingleton's podcast. I know one of the people from the Oriane Society also has a really good podcast with some great speakers. So I'd recommend listening to them.
Okay.
There actually is one So Much Pingle podcast that Dr. Emily Taylor was on and I was talking about her research from just a little while ago. But yeah, we have, she hasn't been on a podcast, I think, since we've started this work.
Why do you guys think there were so many snakes in that rock formation specifically compared to other rock formations?
Yeah, so, the farther north you go and the farther up in elevation you go, the more severe the weather is. And so the more important it is for the snakes to find a good hibernation spot where they can escape the bad temperatures. So we here in like Southern California can get some really low temperatures, and so the snakes will have to go underground, but it's generally only for like a very short period, and there's a lot more warm temperatures. Like we can get temperatures where snakes can be active in January reasonably often. So the snakes around here, generally speaking, don't hibernate as much. Now, go just a little bit north up the coast, like San Luis Obispo and farther north, then you will get snakes that hibernate. But yeah, it's much more casual than like if you were to go up into the Rocky Mountains where the winters are just so much more harsh. So finding a good place to escape those harsh temperatures is much more important, and it's much harder to find those places. So whenever you have a rock formation with lots of nooks and crannies that go really deep, like all of the snakes kind of just have to use the same thing, because there's not enough of those habitat features for every snake to have its own place to hide.
The housing market is.
Yes, it's a very cramped housing market, and so they basically all just get very friendly for half of the year.
I was wondering if you're able to talk about the process you use to mark the snakes. It seems difficult and terrifying.
Yeah. So I didn't do the marking of the snakes, but what they would do is you're able to like use a like hook and like tongs to actually like control the snake, and they then have these plastic tubes, they're like snake tubes, and what happens is like we get the right size tube for the snake, and we have it where the head goes into it, and so it can't back out or like turn around, and so we just keep it in there while doing any like actual manipulations of the snake so that we're safe, and then person that's like holding the actual snake and taking the samples will like take our genetic sample, and then in the case of marking the snake, they actually use nail polish to like actually create the markings on there, and it lasts a while.
I was wondering what the longevity of that was.
Yeah, so it works long enough for it being on the rattles. Of course, rattlesnakes will eventually lose their rattles due to wear and tear. So you can't do it for a snake's whole lifetime, but for like a full active season, you could do it. So you at least get to see how everything is for one active season. One interesting thing, kind of going back to the idea about the UV color and stuff like that, this is kind of an example of where future methods of research may need to be revised, because it actually turns out nail polish really reflects UV light. So all of these marked snakes have like this little tail that's like really bright beacon letting the birds know that the snakes are there. So yeah, so over that active season, they appeared to be fun because we were seeing the same snakes again and again. But yeah, for future work, it might be like we need to figure out a different way to like color these snakes' rattles so that they don't have the UV reflectors.
So what does it mean for each rattle? Like, I think it was the age, or like a big rattlesnake
How
has
many times
like
shed?
a higher, or what is it? Oh.
Yeah, so you can, there's to a certain extent, you can use it to like tell age of a snake, because every time a rattlesnake sheds its skin, it gets a new rattle added to the tail. So theoretically, if they have their initial rattle that they were born with on the end, you actually can estimate how old they are. But the trick is, like, rattles eventually get worn off, and like they're moving through brush and around rocks and stuff like that. So eventually these older rattles become really frail and break off. So if they no longer have the birth rattle, you actually don't know how many rattles they have created over their lifespan. So it's kind of more limited. Overall, it's really just at that early part of their life a good indicator of how old they are.
They also may shed more frequently if they're eating really well or
Yeah.
not.
Yeah, that's another big thing too, is that the seasonality affects it a lot. So like years like this where it's really wet and there's so many rodents, like the snakes are probably going to be more healthy. And they also can change when they reproduce more, depending on the seasonality too, which I think is kind of crazy. So like this past season, we didn't get many babies at the den because the year before was a dry year. But this past year was a wet year. So more of the females probably are going to produce this year because it's a year after a wet year. So, which is kind of crazy to think about. It's not like right when there is a for sure good year. So yeah, the seasonality and the weather really does impact their behavior a lot. Yeah.
Just, you were showing about different animals come to the den,
Yeah.
and I saw that bird, would they eat a bird?
Flew over.
Oh,
No,
you
no, that
mean
one where it's like
the
hanging out
boar
at
The
night.
poor will.
The poor
yeah,
one sitting.
yeah.
So I did notice he was there at like 5 in the morning.
You mean this one right here?
Yeah, that one.
Yeah.
Didn't seem like a good idea to me.
Oh, no.
They like.
And you were talking about coyotes. Would coyotes eat snakes?
Yes.
Okay.
Yeah.
But the snake might eat that bird.
Yeah, it could happen, and like there are rattlesnakes that will eat birds. Like our local rattlesnake will regularly eat birds if like they get close enough in like an ambush position. Speckled rattlesnakes in the desert will also eat birds. But this bird might be a little big, but also it probably is able to like tell whether there's snakes there or not. Because it has really good night vision, so you can probably see them.
Why is that bird hanging?
Again?
Why is that bird hanging out there where there's a snake den? Is it warm?
So that's a good question. It could be warmth. And we were talking about whether the rocks have like warmth at night. And poor wills actually do like to sit on warm surfaces at night, so that could be part of it. Could be also there's lots of insects there too, because
We saw a spider earlier on that one.
yeah. The chances are like it's not just the snakes that are using these hibernation dens. There's probably also invertebrates and other stuff that are also seeking shelter in there. So they might be coming out of like those dens, and then the poor will is just kind of waiting there for its food to come out.
Growing up and there's always, you told the good snakes and the bad snakes, but always like they kill the rattlesnake, on your property or whatever. And if you call the shelter, they'll kill the rattlesnake. So what is it like in today's time? Do they realize, or is it not good to kill a rattlesnake? I mean, you should relocate it, or or is it okay, or do you suggest it's like against the nature, what is it called, the nature of life, or whatever they call it?
Yeah.
You recommend not ever killing rattlesnakes. I mean, someone kills all snakes. I say, don't kill the snakes, they're beneficial.
Yeah. So our stance, and Dr. Emily Taylor actually has her own snake relocation services called Central Coast Snake Services. She offers for San Luis Obispo County and Santa Barbara County. And our lab stance on it is that really we don't want to like have rattlesnakes killed. We think that they should not be killed. They have important functions in the ecosystem. They have a right to exist there. So basically, the thought is that if you need to have a rattlesnake relocated, that's the best option. If it's in a place where it can't be, that you call like someone who's permitted and trained to relocate rattlesnakes and to have them take care of it. And yeah, not to like actually handle snakes, because we don't want the snakes to get harmed. We also don't want people to get harmed too, because when you actually mess with a snake, that is generally the times where it's more likely to strike, and so you can get hurt. So in general, like if you do need a snake to be moved from a place that it's not safe to have it, definitely call someone who's trained to relocate snakes and have them do it.
But the plastic trash kind of always works, and then I have a shovel. Done it a few times. I scoop it, and then I have the lid, and then
Yeah.
I take it in the car.
It definitely is better though if you have someone that's more trained and familiar with working with snakes to do it. Yeah, because they have more experience with that. I know,
If you call division, Krista Groove will do it.
Yeah.
Deborah's here somewhere. But if you call here, Chris lives 3 miles away, he'll move them.
Yeah.
He does it all the time.
I was just gonna say that.
Yeah, okay. I know where Deborah went, but she.
Yeah, yeah.
Another reason to call a professional is they are more familiar with the snake's needs. And so they may move the snake into a place where he is able to kind of recover from that move versus putting him in the wrong type of habitat or.
Yeah. Yeah.
I went to the canyon, it was like where I used to live, it was like I just brought in the thing and then put it further over where that dam is over there,
Mhm.
just
Yeah.
did that, you know.
Yeah.
And
Yeah,
they
yeah.
Something heard me do, well, don't put over here, I put over there, but they, my brother called the shelter and they were gonna kill it, and I said, no, don't, so I quickly got away and then let it go.
Yeah, I think that's the fire department's policy too. In some places, they just automatically will kill the snake. And we need to re-educate the fire department.
Yeah.
The snake didn't kill my rabbit, so I said, well, he needs to be rewarded, so I wanted to.
Yeah, yeah. There's definitely like a certain distance that like snakes can be relocated. Is like if it's like more than like 2 or 3 miles, it's like it's too far. In fact, generally with Central Coast Snake Services, what we do is we just have it where it's like quarter mile, like half a mile away.
I just do the same area, just like.
Yeah, because the farther away you put them, the least likely they are to survive. So we try and get it where it's going to work well for the snakes and for the people. So it's moved away from the problem issue, but not too far away where the snakes are not going to survive. Yeah.
Do you know, has anybody ever done any work with like artificial dens, putting snakes in there to see if you have like 10 artificial dens and 10 snakes, will they each distribute themselves evenly, or will they still cluster in their favorite one, you know, out of preference?
He's not supposed to walk in.
Yeah, there has been some lab studies on like the huddling behavior of the snakes. It's like hard to create artificial like dens, so I don't know if there's been much on that specifically, but yeah, with the snakes huddling together, they've had it where like they'll have snakes in these huddles, and for one of them they'll like have it where the temperature goes down, and then the other they'll have it where like the temperature is like the same. And they found like the ones where the temperature is going down, they'll stay in the huddle longer. So they do think that it is to kind of maintain like their heat and reduce the heat loss.
So there's a benefit for them clumping up.
Yes, yeah, and there's been a few studies that have like shown the benefits firmly of like them being in those groups. But there's also other possible factors like if they're losing water for their skin. So I'm kind of hoping like by looking at humidity as well, that I'll be able to see, you know, maybe it's the water loss that's like another thing impacting that.
The technology that you're using now, it's all developed on campus, on site with existing. I guess I'm curious, is there a benefit over time, especially with more miniature cameras and such, to actually get something inside one of the dens, or is that in terms of data that you might be able to gather as well? So the observations are essentially at the opening or external observations as opposed to internal observations of what's happening inside these large dens?
Yeah, so
I know you're trying to be non-invasive.
yeah, so we don't have anything to go into the dens,
Yeah.
and that's probably very difficult to do because of just the like, you know, this like these rock cracks. It's probably like all sorts of like twists and turns, hard to get in there. As for like the technology, it's like all the different parts, like we haven't had to create any parts, but to get them all assembled together so that they do what we're working on. Like that's all had to be figured out, how we can create a system that's gonna do what we want to do out in this remote location.
I just remember a story growing up, my sister, we always had horses, and my sister's thoroughbred Sugar, he jumped over a rattlesnake, it was on the canyon. So it's like, it was good that neither, did get bit, so it's like, I guess horse knows and just jumped over it.
Yeah, most of the time, like if you just leave them there.
Yeah.
They're gonna do their thing, and they're not gonna bother you. They are much more fearful of us than we are of them. So
And we're the giant predators in
Yeah,
this
yeah.
scenario.
yeah.
Oh, I was saying we're the giant predators in this
Okay,
scenario.
okay.
Yeah.
Yeah.
All right. Well, thank you everyone for having me.
Thank you.
The new camping starts in late April, early May, so definitely check us out. They've got the biggest PR challenge.
Hopefully they'll keep doing if these are for information, I can pass it out the next few meetings.
Yeah, just to kind of get the word out. I
Yeah,
think
I'll
I'm not
take
the most
some
new on the new stuff, but
That's all right, I get
just-